Hello and good day. We are back in Algebra CO19, talking about relations yet again, but now in the context of whether or not that relation is a function. Okay, what do you know already about functions? You told me that you are familiar with the term function table, but what does that really mean? You can't spell function without fun, so let's get to it. Okay. A function is a relation, so a collection of ordered pairs, right? XY table, graph, or whatever. A relation for which every input, which if you recall is X, has exactly one output, which if you recall is the Y. A relation for which every input has exactly one output. And this is one of those definitions where it might be easier to see it rather than reading it. So these two tables here are examples of functions. Because if you look at the x values, 2, 5, 8, 4, there's only one output, one y value that corresponds with it. When x is 2, y is 9. That's it. When x is 5, y is 7. When x is 8, y is 10. When x is 4, y is 18. Okay? Even if y repeats itself, like in this example here, that's okay. When x is 8, y is 10. There's one corresponding output to the input of 8. When x is 9, y can still be 10 because that is the one corresponding output to the input of 9. When it's not a function is if we've got two of the same x values, because now we're saying that when x is negative 2, y can be 7 or 10. That's not a function. In that situation, that input has two corresponding y values rather than one. Okay. This example here, we've got three of them, right? When x is 1, y can be 6, y can be 10, y can be negative 9. That's a problem. That makes it not a function. Okay. The great metaphor that I have here is like birthdays. Raise your hand if you know that you have the same birthday as someone else here at school. Someone in the grade or a grade above you, below you, or whatever. That's okay, right? Different people can be born on the same day. There's only 366 of them every 4 years to choose from. So, it's going to happen, right? But it doesn't work the other way around. Okay, you cannot be born on two different days, right? Every person has one birthday. Okay? 11 every year. Well, yeah, but what if you're like no. Your birth time is on a day, right? You have one birthday. Okay? There's one output for your input, right? If you think of people as the inputs, they got one output, one birthday, right? It's okay for person 8 and person 9 to be born on the same day. That's fine. That'll happen. It's not so okay for the same person, negative 2, to be born on both day 7 and day 10. That doesn't make any sense, right? So that's kind of what's going on here. When we talk about these functions, for every input has exactly one output. Think of it as birthdays, okay? Y can repeat. Two different people can be born on the same day, but the same person cannot be born on different days, regardless of all your what ifs, okay? All right. I know. It's just best to shut those what ifs down now, otherwise we'll go on a tangent that we cannot recover from. Okay? And so again, folks, we're going to be looking at different examples of relations, an XY table, and then the graph. And there are different methods, depending on what you're looking at, to determine whether or not that relation is a function. Okay? In the first one here, does every x value have only one corresponding y value. Okay? Yes. When x is -1, y is 5. When x is 0, y is 5. When x is 1, y is 5. When x is 5, y is 1. Essentially, x doesn't repeat. Okay? It's okay that y repeats. We talked about why that is, right? Different people, 3 different people are born on the same day. Great. That's okay. So yes, this is a function because x does not repeat itself. For every x value, there's only one corresponding y. How about the second one? Function yay or nay? Definitely nay, right? I wish I had 4 birthdays. That'd be fun. Okay? But the x value of 3 can't be 6, 7, 8, and 9. The same person cannot be born on 4 different days. Right? X repeats, so no, it is not a function. How about the third one here? XY table. Function? Yes. X does not repeat. Every x has only one y. So we're good. Okay? When looking at a graph, right, you're kind of deciding the same thing here. You can look at this V shape, and oh, by the way, does anyone know what kind of equation that's the graph of? So you know those absolute value equations that you worked with in CO11? If you were to graph that, it'd be a V shape. Pretty cool. Okay? We'll get to that later on. But anyway, I mean, for the x value of -3, if I pick out -3 as my x, how many y values are there when x is -3? Just one, right? I can kind of draw a line up to it. There's only one x, or one y, when x is -3. How about when x is 1, 2, 3, 4, +5? How many y values are there when x is +5? Just one. All right, I can draw a line up to it. There we go. Just one. Over here, in the second graph, when x is 2, how many y values are there? There are 2 of them, right? I can draw a line up to a y value here, and I can go down to a y value there. So which one's a function and which one is not? The first one is, right? Because when x is -3, there's only one thing y is. When x is +5, there's only one thing that y can be. The second one, though, when x is 2, y can be either about +2 or it can be about -2. That's a problem, not a function. Okay? And this key point up here, where we talk about the VLT, that stands for the vertical line test. And the vertical line test says that if you can draw a vertical line anywhere that touches the graph more than once, kind of like we did here, it's not a function. Because what that represents is that, for this x value of 2, my vertical line touches the graph in more than one place. That means there's more than one y value for that given x. Here, I can draw vertical lines wherever I want, and I'm only hitting that v once. Right? That is a function. There's only one y value for every x. Michael?
Is the vertical line test like tried and true? Is it 100% every time? If it touches in 2 places, it's not a function.
It is tried and true, yes.
But if it only touches in 1,
it is
always
a function. Yes.
Always.
For the graph that's represented. I mean, is it possible for this graph to loop around back on itself, maybe somewhere over here? I suppose, right? But for what's shown, yes, it is something that you can trust reliably. Okay. The third one here. Is there any x value that I can identify that I can draw a vertical line to more than one y value? Doesn't seem to be, right? Every vertical line that I put through here only hits the graph once. What does that mean? Function or no? Function. Indeed. Last one here. It is kind of tough to see. Every year I tell myself, I should get a different graph for this because it is kind of difficult to tell whether this continues to expand outward here or if it does go vertical. It's meant to expand outward, slowly expanding outward and outward. So if we assume that to be true, which is what the intention is, okay, that last one, function yay or nay? Yay. As long as this continues to have horizontal movement, okay, it's going to be a function because if it continues going out to the left there, any vertical line that I draw is still only going to hit it once. There's no spot where I'm going to get a second Y hit. Oof, I can't draw vertical lines very well. That's what I learned. Okay? But as long as it continues to go outward and not turn vertical, then yes, this will be a function as well. All right? We are nearly out of time, so I will wrap this up. Any questions on what we talked about here? Okay. Yes. Okay. There's only, I think, one more thing left on the page here. Oh, I got to put the marker back in the holder, otherwise it's not going to let me scroll down. Very picky. Okay. The ordered pairs of a function are 4, 3, -2, 1, 3, 6, and 0, -5. As this is written, and picture it as an XY table. They're written out, horizontally here, but picture them, XY table-ish. Does X repeat itself in these 4 ordered pairs here? No. So as they're written, is it a function? Yes. Your job is what is an ordered pair that could be added to make the relation not a function. So currently it is. What ordered pair could you add that would then make the relation not a function? That question needs to be answered along with the second page of CO18. That's all the homework you have for the weekend. When you finish it in 10 minutes, think of me correcting all those tests. But what? Hold on, folks. Hold on. I haven't signed off yet. We've got a question. Just you can watch those 5 minutes on my YouTube channel. Don't forget to like and subscribe. That's how you math.